Hello students, welcome to my YouTube channels. Today my topic is concept of shear force and bending moment diagram for the simply supported beam carrying the UDL load. So before video already cantilever beam, point load, uniformly distributing load, uniformly varying load we did, and simply supported point load also we did. Already video uploaded, so you can watch my video. Now I am going to discuss basic concept of the simply supported beam carrying the UDL. What is the shear force calculations and shear force diagram, bending moment calculation and bending moment diagram. So simply supported beam, as we know, first we have to find the support reaction. So AB is a beam and entire length, entire AB beam we have UDL, W kilonewton per meter. So what is the support reactions first? Support reactions already we know. Two equilibrium equations will substitute. Total vertical force will be 0 and moment about any point or moment about A will take will get the two support reactions. So in this summation of vertical forces 0 meaning is total upward force equal to total downward force will find out. So what is upward force here? You can say here RA, this is the concept, upward equal to downward. Or here sign conventions will take upward is positive, downward is negative. So suppose upward is positive, downward is negative. So finally what we will write here? Upward is equal to downward. That's why we are doing this work. Okay, total upward. So sign conventions here will not assume. So that will make more complication. So you can write here RA plus RB equal to what is the load? W kilonewton per meter into length. So W into L. So see here W into L. What is unit? Kilonewton per meter. Here meter. So what it becomes here? WL into kilonewton. So load unit is kilonewton. Always UDL will be there. Will convert load per unit length into length will come load. So this we have to convert. Now see moment about A will take 0. You take B also, nothing wrong. So we are taking A equal to moment. So moment will take clockwise. We'll take clockwise is equal to anti-clockwise moment. We'll take total clockwise is equal to total anti-clockwise. This is the concept. So moment A point is fixed. What is UDL coming? Due to this beam will rotate clockwise. So what will be the load? W into L into L by 2, half distance. Because UDL concept you see here. Already so many times we discuss. If UDL moment we are taking AB. This is W kilonewton per meter. This is L meter length. L meter length. So you know UDL is rectangular road also. Rectangle means we have to take the middle point, half distance. If that you are not able to understand, now you see this maximum deflections where? In the middle. So if you draw the load diagram for this, what will be the load diagram? This one, middle. So this is L by 2, this is L by 2. L by 2. So once we will take the moment about A here, so what will be the load? Load is W into L. W into L is load. Now this becomes point load. So what is the moment about this is B, this is A. Here already there. So take moment about A now. What will be there? WL load into perpendicular distance. Load into perpendicular distance into L by 2. So that only you wrote, I wrote. So either you should remember if UDL will be there, load into half distance. That is called center of gravity point. Or convert into load diagram. Convert into load diagram. Take the load into perpendicular distance, force into perpendicular distance is the moment. Now this is the clockwise rotation. Now this RB from A, RB anti-clockwise rotation. So equal to, because I taken anti-clockwise equal to clockwise equal to anti-clockwise. So RB, this suppose RB, this is RA. Now here RA and RB. So RB into entire length, what is L? So this is the moment about this. So total clockwise is equal to total anti-clockwise. If UDL will be there, you take the point load to calculate the moment. That is the easiest way. Or if you know that concept, half distance, that also okay. So if you are confusion, any UDL load will be there, convert into load diagram. Load diagram means total UDL ka half, middle. Because why middle? Because this UDL, due to the UDL, uniform distributing load, that beam AB will deflect this way, parabolic. So middle will be the maximum deflection. This will be the maximum deflection. Why maximum deflection means load will act here only. So load will act in middle only. For that only we did this. Okay. So okay. Now what is the RB here? LL get cancelled na WL by 2. Then if you substitute here RA plus RB equal to WL. So RA will come. Okay, write one steps. So RA will come. RA plus WL by 2 is equal to WL. So here half, here 1. So RA will be again half, WL by 2. So RA and RB we know now. So RA we know, WL by 2, RB also know, WL by 2. Okay. So support reactions we know now. Now this part, this what I did, somewhere not down, and use wherever the UDL will be there, convert point load and make this concept to take the moments. Okay. So now we'll take the shear force diagram calculation. So okay. So before the sign convention, section, right side, left side, downward force positive, then this side upward force positive. If reverse, upward force negative, right side, then left side downward force will be negative. This is the sign conventions will follow from the shear force diagram. So I am taking from left side na upward force SA positive. What is SA positive? WL by 2. WL by 2. Then SB will be, what will be there? So SA will be WL by 2 minus, because this right side, suppose we are taking here upward force is upward force left side positive. If we will take right side, so what will come here? W by WL minus WL. If point B, you can say like this, SBL. What will be there? SBL na just before this point. This RB will not act. So WL, this is the load for the UDL. So what will come? Half minus 1, so minus WL by 2. So SBL. If we'll take SBR, that means just this point. L means just before this point, this load. Now they are seeing this reaction force. Before this, now minus WL by 2. If SBR minus WL by 2, and what is upward force? Upward force is positive. So plus WL by 2. So it will come 0. So SBR will be 0. So now we'll do the shear force diagram. Shear force diagram will draw. So before this, shear force, 0 line of the shear force will draw. In this line, shear force will be 0. In this line, shear force will be 0. So we draw. Now A point now what is there? WL by 2. So this is the now WL by 2. And what is coming in this point B? B is coming minus WL by 2. So minus WL by 2. So if we'll see this middle point, suppose somewhere middle point will be, take one point C. So what is the distance? L by 2. This distance will be L by 2. If we'll take the shear force at C, suppose you are taking the middle point, because throughout UDL is there, we can say the middle point L by 2. So C shear force na, this side what is? WL by 2. Then downward force negative. If you are going this from taking C na, RA is upward force. Now this UDL downward means what is this? How will make the load? W into L by 2 into L by 2. So 0. So shear force at point C will be, if you will see the shear force at point C you are bringing here, or take the different color now, it will be easy for you. So if you are taking here, this is the section. Now we are taking the another color will take. So this C point sections I am taking. This point C sections I am taking. This is section for sign convention. So section C. So section C, what we are observe here? Shear force will be 0. So join this line. Join this line. Okay, first we'll join this line. So this is what is plus, this is minus WL by 2, this is WL by 2. This is the C point where shear force will be 0. So shear force will be 0 because once you are taking shear force here, load upward WL by 2, downward negative W into L by 2. So this shear force diagram is over. So you can hatch this line. So this is called, this part is known as shear force diagram. Now we'll find the bending moment diagram. So before this bending moment diagram calculations, bending moment diagram calculations we'll find. So bending moment MA will be 0 and MB will be 0. Why? Because you're taking moment, bending moment point A, so no load passing through this point. If B also taking the right side, no load, so both will be 0. Then we'll take the bending moment at C. So before this, what you'll do now, take one somewhere some section. Take one sections here. XX one sections will take and find the bending moment of X. X in this point. So what will be there? WL by 2 into X minus, this is moment, yes, correct. From this is the distance, suppose you're taking the distance is X. So WL into X, then UDL, this, what is this one? W into L, W into X, W into X into X by 2. So W into X into X by 2. So this you write this like this, or this is nothing but what is RA. So you can write here RA X minus W into X by 2. Because moment na half distance, you are taking about C. So RA na WL by 2 into X distance. Now this load is W kilonewton. So W into X. What is this? W into X and half distance X by 2. So this is the bending moment equation. Now put here X equal to 0. X equal to 0, that will come MA. So it will come 0. Okay, X equal to total length is L. If you put here L, what will coming here? WL square 2, WL square by 2. So it will go 0. So this is the bending moment equation. From there you can find all the point. Now we'll see L by 2. X equal to L by 2. X is equal to L by 2. This distance where the shear force will be 0, bending moment will be maximum. So bending moment will be maximum. So what is X? X equal to L by 2. That means L by 2. In this case, bending moment will come maximum. Substitute this value. WL by 2 into X equal to L by 2 minus W into X equal to L by 2 into X by 2. That means X by L by 4. Why X by 4? Because we are taking now half, they're taking X distance. So X is nothing but, here you can write X by 2. So again X by L is nothing but L by 2. But due to the half, you write half like this, you can understand. What I write to see here. Don't confuse here. X equal to L by 2. W L by 2. X W L by 2. W L by 2. X equal to L by 2. Then half is there. So half we wrote. If you calculate how much coming here. W L square by 4 minus W L square by 8 minus WL square by 8. So it will come WL square by 8 only. So what is the maximum bending moment here? Maximum bending moment is WL square by 8. That we have to draw. MA and MB will be 0. So before this, what we'll do here? Draw this line, extend this line, draw the zero moment diagram, zero line of the moment diagram, where the bending moment will be 0 in this line. Bending moment will be 0 in this line. So we draw. Now this is the shear force at point C 0. That means bending moment will be maximum. Now this is the UDL is there. So another one more concept, what is? Suppose you are drawing the shear force. For UDL, shear force will be inclined line. For bending moment, UDL, shear force will be parabola, curve line. So maximum bending moment where? Throughout the UDL either, no? So draw the curve line. So this point is WL square by 8. So this point is bending moment will be maximum. Bending moment will be maximum. What is sign conventions for this? You see here. This is right, this is left. Clockwise, anti-clockwise will be negative. If we'll see reverse, anti-clockwise will be positive. This side, this is anti-clockwise, this side clockwise, left side. So that's why we taken positive. See this MX we taken now. So this what is? Going clockwise. So this is the going clockwise. So what is this one? This one clockwise. Positive, left side. This coming anti-clockwise, negative. Left side we are taking from left side. So this is the negative. Once you are going clockwise, this is the positive. So this is the sign conventions we follow for the bending moment diagram. So once we'll solve the questions also, you will understand. So for UDL, curve line. UDL for curve line, here UDL for inclined line. These two remember, okay? So this way we can, this is the theorem like, so this is the bending moment and shear force calculations and diagrams, okay? Okay friends, watch this video, share this video to your friends and subscribe the channels, okay? Okay friends, thank you.